Solve problems on mixed strategies for 2 by n games or m by 2 games by using following methods. First, algebraic method. Second, method of subgames. We will read the first question. Solve by algebraic method the game for which the payoff matrix is given in the table.
This is the given matrix where 3 number of rows and 2 number of columns are given, and we are going to solve this problem by using algebraic method. Now this method is used only for the mixed strategy, so we are going to use the rule 3 solve for mixed strategy. Now if we observe this, there are 3 number of rows and only 2 number of columns. So this question is of type m rows and 2 columns. So first there are rows and then columns, so m by 2 games. Now according to the algebraic method, we have to first assign the portion of time, or we can say frequency, for each strategy. So for first we will apply the frequency for the player A. So player A should play strategy 1 for x1 portion of time. So this x1 is also known as frequency. So I will write here x1. Player A should play strategy 2 for x2 portion of time. Player A should play strategy 3 for x3 portion of time. Now in the same way we have to apply the frequency or portion of time for player B. Player B should play strategy 1 for y1 portion of time. Player B should play strategy 2 for y2 portion of time. Now we will write here the equation. So this x1 plus x2 plus x3 is equal to 1. In the same way y1 plus y2 is equal to 1. So I will assign here equation number 1 and equation number 2. Now we will write the other equations also. Now if we observe, here is the first column. Now if I take this, I will multiply these elements in the first column with these frequencies. So I will write here minus 2x1 minus x2 plus x3 should be greater than or equal to v, where v is the game value. Now in the same way I will write the equation for the column number 2, that is minus 4x1 plus 3x2 plus 2x3 is greater than or equal to v. Now I will move for the rows. So for this first row I will multiply with the frequencies y1 and y2. So here for these frequencies, that value should be less than or equal to v. So we will write here minus 2y1 minus 4y2 should be less than or equal to v. Then minus y1 plus 3y2 should be less than or equal to v. Then y1 plus 2y2 should be less than or equal to v. So for each of these equations we will assign the numbers, that is equation number 3, equation number 4, equation number 5, 6 and 7. Now if we observe, we have to find out the unknowns. So how many unknowns are there? 1, 2, 3, 4, 5 and v, that is 6. There are total 6 number of unknown that we have to find out, and we have total number of equations 7. Now we will consider this y1 plus y2 is equal to 1. So we can also write y2 is equal to 1 minus y1. So from equation number 2 we can write y2 is equal to 1 minus y1. Now there are total number of remaining 3 equations. So we will put the value of y2 in these equations and we will try to find out the value of y1 or y2. So now we will take this equation number 5. Now we will convert this in equation ability to solve this problem. So we can write this equation as minus 2y1 minus 4y2 is equal to v, because it is less than or equal to. Then minus y1 plus 3y2 is equal to v, and here y1 plus 2y2 is equal to v. Now we will solve this. So I will put the value of y2 here, that is 1 minus y1. So what will be the equation? That is minus 2y1 minus 4 in the bracket 1 minus y1 is equal to v. So now we will simplify this. So minus 2y1 minus 4 plus 4y1 is equal to v. So 4 minus 2, that is 2y1 minus 4. 2y1 minus 4 is equal to v. So this is one equation. So I will give here the number, that is equation number 8. Now we will move to the next. Now again we will put the value of y2 in this equation, that is equation number 6. So minus y1 plus 3 1 minus y1 is equal to v. So minus y1 plus 3 minus 3y1 is equal to v. Therefore minus 4y1 plus 3 is equal to v. So this will be equation number 9. Now if we observe equation number 8 and equation number 9, right hand side is same, that is v. So we can equate these two equations. 2y1 minus 4 is equal to minus 4y1 plus 3. So I will transfer this plus 4y1 to the left hand side and minus 4 to the right hand side. So it will become 2 and plus 4, that is 6y1 is equal to 7. So y1 is equal to 7 by 6. So that is equal to 1 point something, 1.11 something. Now if we observe or if we put this value of y1 in this equation number 2, then there is inequality. That is, this value is not correct, because value of y1, that is, it should be, we can say that it should be in between 0 and 1. So y1 value should be greater, y1 value should be 0 or y1 value should be 1, or it should be in between 0 and 1. So this value is not correct, because if we put the value of y1 in this equation, then it cannot be equated to 1. Now we will apply here theorem to find out the solution. According to this theorem, we have to show equation in terms of x greater than v, then the frequency related to that is equal to 0. So we will apply here to the first column, all the elements in the first column. So for the first column, frequency is y1. So I will write here the equation minus 2x1 minus x2 plus x3 is greater than v. Then at that time y1 is equal to 0. Now we know that y1 plus y2 is equal to 1. So when y1 is equal to 0, then y2 is equal to 1. Now in the same way we will apply this theorem for the equation in terms of y. So for these equations we have to show these equations less than v. Then minus 2 y1 minus 4y2, if less than v, then frequency related to that x1 is equal to 0. Then minus y1 plus 3y2 less than v, then x2 is equal to 0, and y1 plus 2y2 is less than v, then x3 is equal to 0. But this is not possible, because we know that x1 plus x2 plus x3 is equal to 1. Now we will cross check this. So y1 is equal to 0. So we can say that minus 4 is less than v, then 3 is less than v, and 2 is less than v. Now we will compare these three values. So this minus 4 is less than V, 2 is also less than V. So if I consider V is equal to 3, so if I write here V is equal to 3, then the other two statements, that is 2 is less than 3, minus 4 is also less than 3, these are correct. So this theorem, because V is equal to 3, that means we will write here minus y1 plus 3y2 is equal to V. And this theorem is not applied, so we will take value of x2, that is x1 is equal to 0, x3 is equal to 0. So value of x2, that is equal to 1, because x1 plus x2 plus x3 is equal to 1. Now again we will cross check the values. Now we have values y1 is equal to 0, then y2 is equal to 1, then x1 is equal to 0, x2 is equal to 1 and x3 is equal to 0, and value of V is equal to 3. So we will cross check with this equation. So if I put x1 0, x3 0, then x2 1. So x2 1, that is minus 1. According to this, all these values, we can say that minus 1 is greater than V, but V is 3. So minus 1 is greater than 3. So this statement is not correct. That means our assumption, that is our theorem that we take, this equation is greater than V is not correct. So this is wrong. Now we will apply this theorem to the second equation. We will write the second equation as minus 4x1 plus 3x2 plus 2x3 is greater than V, then frequency related to that, that is all these elements are related to frequency y2, y2 is equal to 0. So when we take y2 is equal to 0, then y1 plus y2 is equal to 1. So we will take y1 is equal to 1 and y2 is equal to 0. Now we will put the values in the equations related to this y1 and y2. So again we will apply the theorem to all the equations, that is minus 2y1 minus 4y2 is less than V. Then in this case, according to this theorem, x1 is equal to 0. Then minus y1 plus 3y2 is less than V, then x2 is equal to 0 and y1 plus 2y2 less than V, then x3 is equal to 0. Now we will put the values of y1 and y2. So all these y2s are 0. So we will take here y1 is equal to 1. So minus 2 is less than V, minus 1 is less than V and 1 is less than V. Now we will compare these three elements, minus 2, minus 1, 1. So minus 2 is less than V, minus 1 is also less than V. So if I take V is equal to 1, then what is happening? Suppose V is equal to 1, then the above two statements, that is minus 2 less than V, minus 1 less than V, these are correct. So if I take V is equal to 1, then here for this case this theorem is not applied and I will write here is equal to V. So because this theorem is not applied, that means here x3 is not 0. So we know that x1 is equal to 0, x2 is equal to 0. So x1 plus x2 plus x3 is equal to 1. So I will write here x3 is equal to 1. Now we will write here or combine here all the values. So how to write? Because according to this assumption that this statement equation is greater than V, then we have the values y1 1, then y2 0, then I have x1 0, x2 0, x3 1 and value of V 1. Now we have to cross check this. So if I put this value in this equation, that is x1 0, x2 0, then x3 1. So 2 into x3, that is 2. So I will write 2 into 1, that is 2 is greater than V, that is 2 is greater than 1. So this statement is correct. Now according to this equation is greater than v, then y2 is equal to 0. But here y1 is equal to 1. So how I can write the equation related to y1? So again I will rewrite this equation, that is minus 2x1 then minus 1x2 plus x3 is equal to v, because according to this theorem y1 is not equal to 0. So we have to write is equal to v because y1 is equal to 1. Then again we will cross check this. So I will put x1 0, x2 0 and x3. x3 that is 1 is equal to v. v value is also 1. So this statement is also correct. So we can say that we have to take this y1 1 then y2 0. So these two frequencies are correct. Then in the same way x1 0, x2 0 and x3 is equal to 1. So this statement is also correct. So how we can write the answer? So optimal strategy for A, that we can write here optimal strategy. So I will write the optimal strategy for A as in the bracket. Now A should use the strategy 1, that is for x1 0 times. A should use strategy 2 for x2, that is 0 times. And A should use strategy 3 for x3, that is 1 time. Now in the same way optimal strategy for B. B should use strategy 1 y1 time, that is 1. B should use strategy 2 y2 time, that is y2 0. And what is the game value? So if we cross check this value of v by putting all these values in equation in terms of x and y, then we will get v is equal to 1. So we can say that game value is plus 1. So this is the answer.
We will read the second question. Solve the following 2 by n game by the method of subgames. This question was asked JNTU Hydarabad B May 2011, PU BCom April 2008.
This is the given matrix where player A is having two strategies A1 and A2 and player B is having three number of strategies B1, B2, B3. Now we will solve this question by method of subgames. So this is the question. If we observe 2 rows and 3 columns, that is we can say that 2 by n games. Now we will convert this matrix, that is 2 by 3 game into 2 by 2 game. So how to convert? So if we observe B is having total number of strategies 3. So each time we will ignore one strategy. So if we observe to the first subgame, we will ignore strategy B1. So I will write here ignore B1. Then for the second time we will ignore strategy B2. So I will write here ignore B2. And the third time we will ignore B3. So in this way we have to convert this matrix in 2 by 2 game. So how we will write this? Now here B1 is ignored. So we will write the other elements 3, 11 and 5, 2. So at the same time we have to write this B2, B3 and A1, A2. Now here also B2 is ignored. So we will write here 1, 11, that is here B1 and B3 and 8, 2. So here I will write A1, A2. Now for the third we have ignored B3. So I will write remaining 1, 3, 8, 5. So here is B1, B2 and A1, A2. Now we will solve this subgame, that is 2 by 2 matrix by arithmetic method. Now if we take the difference in between 3 and 5, that is 3 minus 5 is minus 2, but we will ignore sign and I will write 2 here. 11 minus 2, that is 9. 3 minus 11, that is minus 8, but we will ignore the sign. 5 minus 2, that is 3. Now we will divide it by common number. So 8 plus 3, that is 11. So I will write here 3 by 11, 8 by 11, 9 by 11, 2 by 11. So we can say that A should use strategy A1 with 3 by 11 times and strategy A2 8 by 11 times. So how to write the optimal strategy for A? So for A we can write here 3 by 11 comma 8 by 11. Now we will write the optimal strategy for B. So B should use strategy B2 9 by 11 times and strategy B3 2 by 11 times. But here B1 is ignored. So for this B1 we have to write 0. So optimal strategy is 0, 9 by 11, 2 by 11. So this is the optimal strategy for A and B. Now we will calculate the game value. So how to calculate this game value? So I will take here 3 multiplied by 9 plus 11 multiplied by 2 divided by 9 plus 2. Now we will solve this with the help of calculator. So I will take, that is 27 plus 22 divided by 11. That is 4.45. So this is the plus value. So this is the game value for subgame 1. Now in the same way we will move to the second. Now in this second, if we observe, we will take the difference 1 minus 8, that is minus 7, but we will ignore this sign. 11 minus 2, that is 9. 1 minus 11, that is minus 10, but we will ignore this sign. 8 minus 2, that is 6. Now we will take here the common denominator, that is 10 plus 6, that is 16. So I will take 6 by 16, 10 by 16, 7 by 16, 9 by 16. Now in the same way we have to write the optimal strategy for A and B. So what is the optimal strategy for this A? So for A we can write here, so I will write here, for A should use the strategy A1 6 by 16 times and should use strategy A2 10 by 16 times. Now we will write for B. So for B, B should use strategy B1 9 by 16 times and B2 is ignored. So here we will write 0 and should use strategy B3 for 7 by 16 times. Now again we will calculate the game value. So game value, how to calculate? So I will write here the game value. So 1 into 9 plus 11 into 7 divided by 9 plus 7. So we will solve this. So we will take the help for calculator. So here 11 into 7, that is 77 plus 9 divided by 16. 5.375. So I will write here 5.37. Now we will move to the next subgame. So here is the subgame 3. Now again if we observe the element, so we will take here 1 and 3. So I will, if we observe this, then we will first check out for the row minimum and column maximum. Column maximum. So if we observe minimum value in between 1 and 3 is 1 and in between 8 and 5 is 5. And for column maximum here value is 8 and here is 5. So we can say that here is the saddle point. So how? So if we observe from this minimum value we have to choose the maximum. So we can say that this is maximum. And from that maximum value we have to select the minimum. So this is minimax. So this is, here is the saddle point. So what is the saddle point? So saddle point is 5. So we can say that player A should use the strategy A1 for 0 times and strategy A2 for 1 time. So we will write here the answer, that is the optimal strategy. So for the optimal strategy for A, we will take here 0, 1, and then for B, here is 0, yes, because saddle point is here. So strategy A2 use for 1 time, and for B, if we observe, B1 is 0, then B2 is 1, and B3 is ignored, so again we have to write 0. And what is the game value? So game value is nothing but the saddle point, so I will write here game value is equal to 5. So this value is also plus. Now if we compare the game values, then this is game value for subgame 1 is 4.45 and this is plus sign. So here for subgame 2 it is plus 5.37 and subgame 3 it is plus 5. So all these values are positive, so A is winner. So now we have to say that we should try to minimize the loss. That means he should take the strategy with minimum game value. So in between all these values, this value is minimum. That is, to minimize the loss, this player B should take the or should try for strategy B2 and strategy B3 for 9 by 11 times and 2 by 11 times, and he should not use strategy B1. So this is the answer.